and then freak out about, did I do it later? All right. I feel like I left you with a task. Gulp. That's all right. That's all right. I do want to make a note. I've kind of poked around, checked around, did some research. It sounds like everyone's okay with me just posting a recording or some recordings. They're just going to be from the textbook for Friday. So no meeting on Friday. It's important. Watch videos posted, because they do little bite-sized videos, so it'll be multiple videos, but instead. And of course, enjoy your long weekend. That's important. Oh, cute. How about a little avocado? Apropos nothing. Whee! Okay. So spread the word. Not everyone's here, but you could let them know. Maybe that not everyone's reading the notes either. I'm assuming that they are, but I know they're not. I know. All right. Good. Check. That was a big one. Well, for me. Have to remember. Okay. This is from last day. I said, write these linear equations. So you're given 2 points, right, for both of these. And we're going to write the linear equation. And if you haven't done it, that's okay. We'll do it now. One of the main things that we want to keep in mind when we're making these lines is there's going to be an input value and an output value. Okay, so for both of these, right, identify the input, which is your x, and the output, which is your f of x, but I'll also put y if you prefer, right? If you want to just read those interchangeably, that's fine. They decided they didn't want to go in this class, wanted the other one. But I think the back door's open, yeah? Okay, nice. Then people will find their way. Right? I always used to just read, when I saw f of x, I would just read it as y, and it just helped simplify things for me. It wasn't until I was comfortable with the function notation, right? A function of the input, right? But at your own pace. Okay. We've got a line passing through the points -2, 3, and 4, 0. So -2, 3. So here, let's start with A. -2, 3. First off, we're going to identify the input is x is equal to -2, yields an output f of -2 is 3, which is your y, right? Because in general, these coordinates are of the form x comma y, of course. Yeah. The other point that we were given is 4, 0. It happened sooner than I thought. Let me just make sure I'm not on mute. Okay, phew. Oh, goodness. I feel like today would be the day that something went wrong. 4-0. I guess time will tell. Input is 4. X equals 4. And whether you want to do f of 4 or y is equal to 0, they're equivalent. Right? So we've got the input, we've got the output. As a fact, to figure out an entire line, whether it be the equation or drawing it, you only need 2 points. Okay? Maybe I'll call this an LFF, a little fun fact. To find the equation of a line, or draw a line, which is basically the same thing, right? If you kind of think about it. We only need 2 points on the line. That's cool. First thing we're going to do, we know how to find the rate of change, right, which is the slope. And so step number 1, find the slope. The slope, I'm going to call it m. I don't think we have been, but m is the rate of change, which we know how to find, which is the change in the output over the change in the input. Now, what I'm going to do is I prefer the f of x2 minus f of x1, right? Output 2 minus output 1 over x2 minus x1, which is also the reason, right, why I kind of converted it to f of negative 2 is 3 and f of 4 is 0. You don't have to, right? Just take the first or the second output minus the first output, and then you're all good. So what do we get in this case? We get 0 minus 3. Output 2 minus output 1 over input 2, which is 4, minus input 1, which is negative 2. 4 minus negative 2. I get negative 3 over 6. You can absolutely simplify it if you want. I'm going to be lazy and leave it, but it's also playing it safe, right? Your calculator will simplify things for you, right? And so if you do negative 3 divided by 6, your calculator, and I only mention this because in some of the assignments, it asks for the simplified form. So if you just put the original form in your calculator, it'll just do it. Using the calculator for simplified form. And if you don't know how, then ask me after class. Feels like one of those pyramid schemes. Then send me a message. I'd love to tell you about it. All right. So we have the slope. That's good. Let's see what we're missing here. Step 2 is, okay, we've got y equals mx plus b. We know it's going to be a straight line, right? I guess it didn't say. No, it did. Write the linear equation so we can assume it's a straight line. So then f of x is mx plus b. Oh, trying to match the textbook. I always go mx plus b, but let's go intercept plus the slope times x. B plus mx. Doesn't have that same ring to it though. It doesn't. Right? I don't like saying it that way. It's a little jarring. I think the justification for using it was really good, right? But it's not how I think about it. We start at the intercept and then we increase by the slope for each additional x. So when you read it that way, it makes more sense, I guess. But I still like mx plus b. And they're the same, so it doesn't matter. But what did we do? We just found that, fine, I have the simplified version. And so I'm going to use that for my m. Okay. So now I have f of x is b plus negative 1/2, which I'm going to change to minus, times x. What's the next thing we have to do? We have to find the intercept. Now, if we're lucky, we're given what the output is. Remember the meaning of the intercept is the output, f of x, when x is 0, right? If you think about it in terms of what it means to be the intercept. Right? So here, recall, the intercept is the output when x is 0, right? Which we could write f of 0. And that's a fact, and you can convince yourself. In fact, I tend to rely on the equation to remind me what the meaning of the intercept and the slope are, right? You can kind of use them as your guide. Okay, so with a little bit of luck, we've been given the output when x is 0. Let's see. Oh, darn. We were not. We have the output when it is 0, which is also an intercept, but not the right one. So what do we need to do? Well, I have input-output combinations. In fact, I have 2 of them, right? I know, well, now I've forgotten what they are. I know when x is 4, y is 0, right? I can use that. Those points are on the line. So what can I do? I can remember that, and mostly because I hate dealing with negatives, so I tend to avoid them, right? But you can use either one of these points to find the intercept. So whichever math you prefer. Okay? I'm going to use 4, 0 because, like I said, I don't like negatives. And I don't think I'm alone in that. Here, we know 2 points. Whoa, that doesn't look good. Worse than usual. 2 points on the line. Negative 2, 3, right? Yeah. I guess it's and 4, 0. Right? We can use either point to solve for b, which is also step 2, I guess. Okay. Using 4, 0. You can try it with the other point, that's fine. I'm going to start with f of x equals b minus 1/2 x. So when x is 4, f of x is 0. All right. So here we go. So I get 0 is b minus 1/2 times 4. which makes 4 divided by 2 is 2. So I get 0 is b minus 2, which means that b, doing it all in one kind of switcheroo, right, adding 2 to both sides, but also putting what I'm solving for on the left-hand side because it's nicer to read, I get b must be 2. Okay. Which means that f of x is going to be 2 minus 1/2 x. Putting it all together. We never put values in for x and f of x because that's the whole point. This covers the entire line, so you can put in any x and get out any f of x, right? And we can check our work, right, using Desmos. If we graph this 2 minus 1/2 x, what am I looking for? I'm just making sure that both of those points that we were given are on this line. So here we go. 2 minus, I'm going to put brackets around the 1/2 just for safety. And I get this line here. And what was the other? 2, can't remember what the other point was. Said it so many times, -2, 3. So when x, I don't have a pointer on here, but when x is -2, sorry, when y is -2, y equals -2, I can put a line there to make sure that it intersects. Did I do that wrong? Ha. What did I do wrong? Strike 1, 0. I did y equals -2, but that's not what I wanted. I wanted x equal to -2. That's fine, can do. X equal to -2. And phew. There it is. Let's see if I can keep all these in my screenshot. Phew. I'm gonna crop it up. Oops, maybe not all of it. As much as I can, though. Okay. What does this confirm? Confirms that the points that we were given, right, they're on here. -2, 3, and 4, 0. But also we found the intercept, which is where it crosses the y-axis, right? And so now we connect these points, right? But even if you didn't have the intercept, you could draw these 2 points, take a straight edge, and connect the 2 and extend the line, and then you've drawn the entire line, right? Which is what we did, but in terms of functions, right, that's what this is doing. Using 2 points on the line, finding the general equation, and then we know the entire line.
How are you going to get to show the points on the lines there? I'm like getting that, like the -2 and 3. Like I have the points, but not the actual.
Oh, is it because this one here? Oh, when I, so if you click on the line, here, I'll go back to the, so if it's like this, then you touch the line and it shows up kind of very faint with little gray dots.
Yeah.
And you can click on those, dink, 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 to show them. Yeah. And you can even you can follow the line to find, well, quote unquote, all the points, not all the points, but by some reasonable increment of hundreds. Cool. Nice. So that's how I would check my work if you're kind of unsure. It's always nice to be able to check your work, right? Or maybe not. No, I don't want to. All right, all right, all right. This one. So we did A, that's great. Let's do B. We'll pick up the pace just a little bit, although they called it A again, but we know better. First thing we're going to do, right, is identify the inputs and the outputs. And if we have two inputs and their corresponding outputs, right, not just random inputs, outputs, then we can find the equation of the line. All right. So first thing we're going to do here is x equals 3. Oh my gosh. The strike 2. Output is 3. The input, I'm going to try to not get another strike here. The input is 2. Input is 4, and the output is 7. Okay. First thing we're going to do, find the slope. Find the slope. M is f of x2 minus f of x1. If you prefer to just think of it as output 2 minus output 1, that's totally fine, over x2 minus x1. Okay, output, the second output, how do I determine which one is which besides the order that they're given? Well, you're always going to go from the smaller value of x, that's your input 1, to the larger value of x, that's your input 2. You can mix those up, you can switch those if you want to. You're going to end up in the same place, but you have to be consistent. And I just like to go from a smaller x to a larger x as my second input, okay? Just to be consistent. All right, so output 2 is 7, minus output 1 is 3, divided by input 2 is 4, minus input 1 is 2. Seven minus 3, 4 over 2. I'm just going to go with a slope of 2. Things to notice, right? I guess we didn't talk about the negative slope, but it looked negative on the graph, and so it all checked out, right? Because we had a negative value for the slope. And here we have a positive value, so what am I expecting my line to look like? I'm expecting it to be going up like this, which we'll confirm, but it's good to know what you're expecting to see. Okay, then step number 2, we're going a lot faster this time, is find the intercept. Find the intercept. So we know f of x is b plus 2x. And we were also given 2 points. We know, and you can use either combination. F of 2 is 3 or f of 4 is 7. I'm going to use 2 and 3 because they're cuter. Using f of 2 equals 3, I know that 3 is b plus 2 times 2. So then I get b, right, multiplying the 2 times 2 to get 4, and then I get 3 minus 4 is -1 usually. Nice. So now I know, therefore, f of x is -1 plus 2x. We can confirm by drawing this equation, right? -1 plus 2x, and then just confirming that the points that we were given are on this line. Otherwise, we did something wrong. So let's see here. Did I try splitting the screen? No, this doesn't work. In some rooms, it shows my split screen, and some rooms it doesn't. It's very confusing. -1 plus 2x. Let's x out of these. -1 plus 2 times x. Okay, it's got the shape I was looking for. All right, it's positive slope. And we're given when x is 0, the output is -1. Well, we forced it to be that. So we need to confirm some other points on the line. And we were given when x was 2, we're expecting the output to be 3. So I'm going to put a line at x equals 2 to confirm. X equals 2 should be crossing the line at y equals 3, which it does. Let's put the other point on the line just for completeness. F of 4. So when x is 4, I'm expecting it to pop up at y equals 7. So x equals 4 puts me at, I'll try to get all those points on there and keep them there for the screenshot. They like to sneak off. Let's crop it up a little bit. And right, here are the 2 points we were given. When x equals 2, the output is 3. When x equals 4, the output is 7. So those are on the line, but also we found the intercept, the y-intercept. When x equals 0, we get an output of -1. We did it. Crowd goes wild. Oh, I need to move this down, don't I? Whee! Down here, maybe. Nice. All right. Good. I think there were some examples because there's just a couple of key things that I want to talk about today. Let's see what time I have. What I'll do is I'll solve these in the notes before I post them, but I don't want to do them. But let's talk about how you would solve this one. If you had to write an equation for this function that's been graphed, just remember you need 2 points, and that's all you need to be able to find the line, right? And so what you're going to do is identify just any 2 points. Now there are obvious choices, right? Maybe things where it clearly is at that point, right? Maybe not here, although it's always nice to start out knowing the intercept. Here it's not obvious what the intercept is, right? So you might want to use a different point that you know where it goes through, right? And so you can try that, but so given a graph, you can kind of map it back to the function. And just remember, you need 2 points, and then you have everything that you need, right? Find the slope, find the intercept, put them together, and you're done. If I said this is the exact same type of question, you would say, oh, Emily, you're off your rocker. And maybe I am. But how is it the exact same type of question? You're given 2 inputs with their 2 outputs, and that's all you need, right? It's a little bit harder. Word problems are just harder, right? Because you need to identify which one's the input, which one is the output. Okay, but at age 20, the maximum heart rate when exercising is 170 beats per minute. And then at age 70, the max target heart rate is 128. If the target heart rate decreases, so it's decreasing linearly with age, write an equation relating them. Which one's your input? Has to be age, right? We're told, okay, if you're 20, then here's your output. If you're 70, here's your output, right? And so that's the hardest part about reading this question and figuring out how to write this equation. But once you have those 2 points, then you're off to the races, right? Got your input, you got your output, input, output, and then you go. Okay? So like I said, I will solve these before I post the notes, but I want you to try them on your own. Okay? In fact, I'm going to leave myself a page and a red note. Emily, do what you promised. If I post it with this note there, I did not do what I promised. I'll save this page and insert it here. Let's see here. Same type of question, right? You've got 2 points on the line, and we've already done this, right? Find the conversion equation between Fahrenheit and Celsius. So you already know what you're expecting it to be, but also you can convert these into inputs, outputs, input, outputs, find the equation of the line that way, all right? Okay. Let's see here. Save that whole page. And now I'm ready for the next section, 2.2. I don't like to focus too much on graphing, as you've seen, right? I rely on Desmos a lot because I don't think that there's a lot of value in graphing by hand anymore. Of course, there was a time when you had to be able to graph things by hand, right? Plot 2 points, extend the line, blah, blah, blah. But now we have computers and we don't really need to do that anymore. You can get Desmos on our phone. It's crazy if you think about it. But there are some mathematical components of the graph that I want to talk about. And so that's where I want to focus in this section. Let's see here. For completeness, although we've already talked about this, hey, I don't think it copied. Oh, you can't see what I'm doing. Sneaky. I actually don't like it. I prefer it when you can see what I'm doing and fumbling through it. It's easier to follow, I think. But I don't know how to change it, so. This is just a recap of what we just said. But it's nice to have in a nice clean box here. And so if we have the equation b plus mx, then b is, of course, the vertical intercept or the y-intercept. And it's when the input is 0, we get an output of the intercept, fine. M is the slope, right? And once we have at least 2 points, we can extend the graph of the line to the left and to the right, right? Or construct the equation if you want to get fancy. Okay. And there are some examples. How are we doing for time? No. I'll put it in. That feels like a lot of work that we don't really need to do. Yikes, what would you have to do? Just do the same thing that I asked you to do, right? You have a graph, you find 2 points on that graph, you can find the equation, you're doing it 6 times over, and then you did it. Fine, I'll pull this in, we're not gonna do it. Didn't even do the first one. But I'll put the answers before I post the notes. Wow, there's a lot of that, so there's a risk that I might forget. What are some key things to look out for? Right. First of all, do you expect a positive or a negative slope? That's a good place to start. Right. You know the y-intercept, or roughly the y-intercept of a lot of these. Looks like a lot of them pass through 1. This one passes through -3. Right. So you can pick out little components for a lot of these, but it's going to be good practice. But let's not do that right now. Feels like a waste of time. Okay. Well, whoa, wowzers. We know 2 parallel lines are what? They're 2 lines with the same slope, right? And so they have different intercepts, right? But properties of parallel lines, right? They have the same slope, potentially different intercepts, okay? And they never intersect, right? So some of those things are what I want to focus on today, right? The points of intersection, if there are any, what does it mean mathematically to be parallel or what? Perpendicular, right? And so we'll just talk about some of those components. Now, where is that little, oh, fine, the horizontal intercept. What's the horizontal intercept? I didn't talk about it, although I mentioned it briefly. Instead of the vertical intercept, which is your y-intercept, it's where it crosses. So here, these are your y-intercepts. If you had to guess the vertical intercepts, you had to guess the horizontal intercepts are where it crosses the x-axis, right? Which means what? It means the output must be 0, right? You find the x that makes the output 0. So they go hand in hand. We usually don't spend too much time worrying about the horizontal intercept, but graphically, here it is, right? It's when y is 0, if you prefer y, or if you're fancy, f of x is equal to 0, right? So the value of x when y is equal to, when y is equal to 0. That's fine. Solve it the same way, right? You force the output to be 0 and you can find the value of x that makes that happen. That was a little pit stop on my way to, oh my gosh, so much fun facts. We've already used all these. They're not little fun facts, they're big fun facts. BFFs. But these are also relatively kind of intuitive, I think. Right, horizontal lines, whenever you have the output is just the constant, right? Then you have a horizontal line. we've already talked about that. And the vertical lines, I use this fact, right, earlier when I was graphing these and confirming our work. Wait, here, what did I do? I put in vertical lines at x equals 4 and x equals 2 to find the points of intersection, right? And so it just helps me find the points of intersection. But when x equals some value, then it's just a vertical line like this. Are we going to get to parallel lines yet? Finally. Oh, I've been segueing to this for like 20 minutes. Trying to get us there. All right. Two lines are parallel if the slopes are equal. So now let's put it on a fresh page here. If the slopes are equal, right, then how can we confirm that? Mathematically, if you have solved for slope 1 and slope 2, right, if they are the same, then you can conclude that these two lines are parallel. I'm going to add a little subscript here. I don't like that these are just B's. It's implied that they're different, so I get why they did that. It's to simplify the equation, right? But we have m1x and m2x showing that they have different slopes potentially, right? But if m1 is equal to m2, then they are parallel, right? This makes it seem to me like those intercepts have to be the same, and that's not the case, right? Those intercepts, especially if I have two parallel lines, boom, boom. Oh, that's a terrible parallel line. Looks like they're going to intersect at some point, right? Then I'm going to have two different B1, B2, right? Two different intercepts. If I force them to be the same, then they're always on the same line, and that's not very fun. So that's why I'm adding these little subscripts. But if you don't like them, you don't need them there, but just recognize that they're potentially different. Okay. What's the special case of if both lines are vertical, right, then that's when x is equal to some constant, then it doesn't matter what the slope is because x is always the same. And that's the, I didn't actually want to say that. It's true, but didn't want to go that far. Okay. And this line not looking even remotely parallel is kind of bothersome. There. So here, if we get some change in output over the change in input, m is equal to m1. And if this one is the same, m is equal to m2, right? If m1 is equal to m2, these lines are parallel. I think that's a pretty sellable feature. Do we get to go to perpendicular right away? I'm scared to do my little, oh phew, if we do, okay. Now I'll open up. Perpendicular lines are when they intersect at 90 degrees, all right? And so here, let's see here, Try to match the colors. If I have a line like this, then a line like this, how's your, I think your trig's pretty good from my little glimpse, right? This is a 90-degree angle. So then these two lines are perpendicular, right? 90-degree angle makes these two perpendicular. The relationship between the slopes to me is not obvious, right? And so I tend to use this definition as a crutch, okay? But if I have f of x, and I'm gonna add b1x and b2 just for completeness, b1 plus m1x, and then here I have g of x is b2 plus m2x. Mathematically, to check to see if they are perpendicular, or I could ask you to work the other way, force them to be perpendicular, right? Find the equation of the line that's perpendicular to this line, right? Either way, you need to rely on the fact that they're going to multiply, the two slopes are going to multiply to -1, right? There's a couple of ways that you can rearrange it, right? One of the slopes is going to be the negative reciprocal of the other slope, right? Hey, it's even here. Nice. And so we need to remember that, I'll just add it here. If m1 times m2 is equal to -1, right? And you can rearrange that however you want. Okay? These lines are perpendicular. I'll add a little note here. Note. Often I'll ask you to find the equation of the line perpendicular to some other line, right? So then you need to rely on this fact and work backwards, right? Then you need to find the slope, right, with -1 over the original slope as its slope. Okay, so here, often I will ask you to find the equation of the line perpendicular to a given line. Right. Which means that you're going to use m2 is -1 over m1 to solve for m2. Once you have the slope of the line, right, what are you going to do? You need to find the point of intersection, leading me potentially to a nice definition. Maybe. And I happen to know there's no green box for this, and I think that's maybe a mistake. But that's okay. So as long as two lines aren't parallel, right? If they're parallel, then they're just going to run alongside each other and never intersect. But if they're not parallel, even the slightest difference in slope, eventually they will intersect, right? And so what we often have to find is the point of intersection. Yeah? And so what we do is we say, okay, well, they're going to intersect at the point that satisfies both equations, right? I need to find some point where the same input gives the same output, right? That's the point of intersection. So if I just draw a generic graph here, the point of intersection of, let's say, something like this and maybe something like this. I'll make this a nicer line. Right here, this is the point of intersection. And what we rely on to find this point of intersection is that, okay, for both of these, if I give it some value x, then the output for both of these is going to be the same. Or maybe I'll call it A. Usually we use, strike 3, I'm out. There. But I didn't write the whole thing, so 2.5. Usually we use x if it's changing, and A if it's some fixed value. It doesn't matter what it is, right? But I'm forcing it to be A. Then the output for both of these lines is going to be f of A. So what can I do? I know the output has to be the same for both of these, right? So usually what we do is we set them equal to each other, right? Take the first line, set it equal to the second line, right? And then, so here, for example, if f of x is b1 plus m1x, and g of x is b2 plus m2x, two generic straight lines, different slopes, different intercepts, right? To find the point of intersection, what I'm going to do is I'm going to say, okay, well, if I give it the same input, they have to have the same output by definition of the intersection, right? And so what I'm going to do is I'm going to force these to be the same. What's that going to look like? I like to kind of put them back to back, if that makes sense. So what I do is I say, okay, well, b1 plus m1x is equal to f of x, which is equal to g of x, which is equal to b2 plus m2x. This becomes redundant, right? Because I'm forcing them to be the same. And so what can I do? I can cut out the middleman and say that b1 plus m1x has to equal b2 plus m2x. So now we have these things. It's just a chain. If A equals B and B equals C and C equals D, A equals D, right? That's a fact. So now I have b1 plus m1x is equal to b2 plus m2x. I'm just showing you why you set them equal to each other to solve for the point of intersection. If this, I know a lot of people don't like this. What are you doing here? Right? I'm just putting them back to back, right? Because of the fact that if they intersect, right, then they're going to have the same output at some point. Now our goal is to find what value of x gives me the same output, right? So it doesn't matter what the output is, they're going to be the same, so I can smush them together. And what I can do then is I can solve for the x that makes that happen. Right? So now, solve for the x that makes it true, that makes this true. Okay. With these general variables, it's hard to see, right? But that's what we would do. And then what? Then I know the input. So now I've found this point, right? Then I can use f of x, or I can use g of x, or I can make sure that it works in both. But what am I expecting? I'm expecting them to be the same, right? So now you can plug them in and find the output, and then you have a set of coordinates. Then use this value of x to solve f of x. I'll say and or g of x. They'll be the same, right? Make sure they are the same. Right? Then the point of intersection is at the x and f of x you just found. We'll need an example, otherwise it's tricky, right? But you need to, so to solve for points of intersection, you need to rely on the fact that at some point, the point of intersection, the input is the same, yielding the same output. Okay. And I think there are some examples kind of leading up to this. Fine, do we want to do this one? I kind of want to get to the intersections while it's fresh. So I'll add this in, but what are you supposed to find here? All right, find the value of x when the output is 0. Sketch these, no thanks. This one we can do, and let me just make sure. Okay, we're doing all right. Doing all right. Given a series of slopes, we want to find the slopes parallel and perpendicular to. Backtracking a little bit, but nice warm up. Let's see here. I'll break it up like this. See if I can get away with it. And it's only because I'm dealing with a page break here. There. Gonna get tricky for the perpendiculars, but I'll work across the page. If the slopes have to be parallel, what was the number one thing that we know about parallel lines is that the slope is the same. So that's a gimme mark. If the slope is 2, then the slope of the parallel line has to be 2. And that's going to be the same for all of these, right? The parallel lines, they all have the same slope because that's what it means to be parallel. M is 1/2, M is -1/3, M is 3/4. Now the perpendicular lines. First we said, okay, the two slopes multiplied together have to make -1. that's hard to backtrack from, right? You'd have to rearrange it every time. And so what I would say is I would just do it once, right? M1 times M2 is -1. I'm trying to solve for the perpendicular slope. I'll call it M2 must be -1 divided by M1. You can rearrange for either one of these, right? I'll put these on your formula sheets, but I'm just curious. I always just prefer to have as few formulas as possible because I get overwhelmed with too many options, and I start to think that they're different when they're actually not. They're just derivations of one. What's your, or do you like to have them all worked out? I don't know. Well, think about that. Think about what you would like. Right? I can always put all of them on there, all the different reworkings, and then you can ignore them. But like I said, I, as a student, used to get very overwhelmed until I realized that these are all just one function and they've just been rearranged. It's weird. So I'm the type that I just want to have one and then I can solve for what I want. But think about what you like. It's important. So here, if we call this M1, right, that's our kind of initial slope, then we can solve for M2. M2 is -1 over M1, and I am going to go across the page here because, well, I'm lazy. -1 over 2. That's a slope. I don't need to simplify it. Right? Some of these will require simplification, right? Such as this next one, M2, again, is -1 over M1, which is -1 over 1/2. Fraction over fraction, right? I have to flip the denominator and multiply, right? Flip and kiss. And so this becomes -1. I like to put it over 1 just to show it as a fraction, right? -1 here in the numerator is just -1 over 1, right? And then that way I can multiply it by the denominator, which has to get flipped and multiplied 2 over 1. Multiplying fractions, I can just multiply across, right? -1 times 2 puts me in -2 over 1, which I'm not even going to write. Right? And back off. Okay. How about the second one? -1 over -1 over 3. Oh boy. -1 over 1 again. Times, and I'm putting brackets around it because the next one is negative as well, and I don't want it to look like subtraction. And so if I flip -1 over 3, and I always put my fingers on it and then I flip it, because otherwise I have a hard time seeing how it flips. But then I get -3 over 1. -1 times -3 makes +3. And then finally, M2 is -1 over 3 over 4. I keep wanting to drop the negative. That's bad. Same thing, -1 over 1 times 4 over 3 is -4 over 3. Nice. The negative reciprocal. Cool. Step it up a notch. Okay, maybe parallels are easier. Let's start there. Oh, that's huge. Find a line parallel to. There. Find a line parallel to 3x plus 1 that passes through 0, 2. or 0, -2 rather, doesn't matter. Okay, what are some things that we know? If it has to be parallel, then if M1 is 3, right, that's the initial slope, then M2 also has to be 3. And I'm going to use my, right, because I know people don't like it when I do this. Neither does my iPad, I guess. Right, when I say M1 has to be equal to 3, which is equal to M2, right, I'm just joining these things that are equal. And then I can jump between them. M1 is equal to M2, M2 is equal to 3. All right, so that's the first thing that we know. So now I can start to put it together, right? If I have f of x is equal to b plus m2, which is 3 times x.
So we're that right? It's like b plus mx, but the questions are mx plus b. It's annoying.
It is annoying because he made such a point of being like, this is how we're going to write them. Well, old habits die hard, I think. Now we're back to the exact same type of problem that we were solving before, right? I have the slope. I need it to pass through this point, which means that when x is 0, f of x is -2. So then I can use this and say, okay, -2 is equal to, oops, that's not true. B, I'm trying to get all fancy with my colors, but b plus 3 times 0. It's a nice soft row y. Now we have it. He gave us the intercept, right? When x is 0, y is -2, but it's always good to just follow through, but you know what you're expecting b to be. B to be. BB. You're expecting b to be -2, so you get -2 is equal to b plus 0, or b is equal to -2. Therefore, f of x must be -2 plus 3x. Is the parallel line that passes through 0, -2. Nice. Where's that little rascal? Perpendicular now. Find a line perpendicular to the same line that passes through 0, -2. Okay. Let's remember that if it's perpendicular, and here we have m1 is equal to 3. M2 is -1 over m1, which is -1 over 3. Right? So again, the first step is finding the slope, right? It's always going to be finding the slope, just different ways of doing it. Then finding the intercept, which we know is -2, but let's just go through the motions again. F of x is b plus -1 over 3, which I'm just going to make -1 over 3x. Again, -2 is equal to b -1 over 3 times 0. Oops, just trying to match them. 0. So b is -2 again. That checks out. In fact, I'll even use less space here. Which means that f of x must be -2. The slope was -1 over 3. So minus 1/3 times x is the line perpendicular to the given line passing through 0, -2. Whoo! Okay. I feel like, is that the, you know what, I have a feeling I know what they wanted to do, since it's the same function as before. And let's do one of these lines that we just found. Since this is 3x plus 1 and the original one was 3x plus 1, why am I not going to use the first one? I could, but they're never intersecting because they're parallel, right? That's one of the properties of parallel lines. So how about I find it for the perpendicular line? Right? That's a good place to start. And we said that these two lines are perpendicular. So, and I'll call it g of x just for a different function name. You can call it f of x, but they're different functions. They're giving you different lines. So that's why I'm giving it a different name. -2 minus 1/3x. Okay. The point of intersection is when these two have the same input, they give the same output, right? And so we use that fact and we set them equal to each other. Step 1, set the functions equal to each other. Equal to each other. And solve for x. So I like to put them back to back with the function names next to each other in the middle so that I can kind of dissolve them. Does that make sense? If it doesn't, that's okay. You'll see. 3x plus 1 is equal to f of x. And then what I'm doing is I'm forcing it to be the same as g of x, right? I need them to have the same output. So I'm forcing that, and it has to equal -2 minus 1/3 times x. These, right, I don't need these anymore. I shouldn't use red. It's not wrong. It's just, I want to, boop, boop, boop. Where's like a gray? There. So then 3x plus 1 is equal to -2 minus 1/3x. And we want to find the x that makes that happen. What do you have to do? Collect like terms, right? Put x's on one side. Sometimes it's easy to move everything to one side and collect like terms. And so with practice, you'll kind of be able to see what you like to do. For me, what I'm going to do is I'm going to move everything to one side. And why am I moving this over to the left-hand side and not the other way? I hate negatives. Right? And so you start to see things, well, I don't want to be dealing with a ton of negatives. That's terrible. I don't like that. Right? Maybe you love negatives. Then you would shift it the other way. Right? But it doesn't matter. As long as you're working around the equal sign, it's all good. 3x plus 1. I'm going to do all of these at the same time, individually, technically, but I'm going to add 2 to both sides, and I'm going to add 1/3x to both sides, which leaves me with plus 2 plus 1 over 3 times x is equal to 0, right? I've added everything, so now there's nothing on the right. Okay, so now I need to collect like terms, collect these x's together, and first I'm just going to regroup them. 3x plus 1 over 3x plus 1 plus 2 is equal to 0 still. Pulling out this common x, I get x times 3 plus 1 over 3 plus 3 is equal to 0. Adding fractions. Now, I'm going to go out on a limb and say that your calculator will just do this for you. 3 plus 1 over 3. Let me try it. I think it will. Yeah, gives me 10 over 3. Why? I have to have a common denominator, right, to add or subtract fractions. And so what do? I like to just force it to have the same denominator. So I multiply by 1, convenient value of 1. That doesn't change the value, right? But it becomes times 3 over 3. So now I have x times 9 plus 1 over 3 plus 3 is equal to 0. So then I have x times 10 over 3 plus 3, or 10 over 3x if you prefer, is equal to 0. Now I can solve for x by taking x times 10 over 3 is equal to -3. I multiply the 3 over and I divide the 10 over, which is the same as dividing by a fraction, right? And so now I get x is -3 times 3 over 10, putting me at -9 over 10. Whoo! Now, what can you do? Well, when you live in a shoe, I'm almost out of time here. 1 minute left. You can put in that value of x to find out what the output is. Right? So if f of x is 3x plus 1 at x equal to -9 over 10, then I get f of -9 over 10 is 3 times -9 over 10 plus 1. Oh boy. 3 times 9 is what, 27? -27 over 10 plus 1 is some number. And with my no time left, I'm going to put these 3x plus 1. That's my first line. The second line I found was, oh shoot, -1/3 times, oops, 1 over, oh my gosh, 1 divided by 3 times x minus 2. Whew. And there it is. So you could find the point of intersection graphically very easily. So it's a lot of math work, but you can also check your answer with Desmos. All right. No class on Friday, but I'll post some videos for you to watch. Enjoy your long weekend. That's important. And I guess I'll see you in a week. Weird. All right. Oh. It said my screen sharing ended. I wonder when.